This is the third in our 6-part webinar series on the water crisis and environmental health. This is Katie Mauman. I'm the Water Initiative Coordinator with the Public Health Alliance of Southern California. And I'm joined at the controls here again today by Holly Calhoun, our Food Systems Working Group Coordinator. Just before we get started, I wanted to let everybody know that we will be recording today's webinar and posting the recording, the presentation slides, and a few other resources on our website. Please go ahead and share that link with any of your colleagues who are unable to join today, and we'll be sending you that link in a follow-up email. Everyone has joined today's webinar in listen-only mode, which means that your audio lines are muted. And we will be asking you to raise your hand. You can type questions for the panelists anytime by typing into the question box on your control panel. And raising hands, you can just go ahead and click on the button with the hand symbol on it. And we encourage you to raise your hand and participate in the discussion. And we really want to hear your thoughts, your ideas, and your questions so we can really get the most out of this webinar, as well as our just broader effort to support environmental health around these issues. So if at any time you experience technical difficulties, please feel free to send a question to one of our staff in the control panel, or you can call GoToWebinar at this number. So at this point, I just turn the floor over to Angelo Bellomo with the LA County Department of Public Health. Angelo's been a great partner with us on this series and is going to be introducing our speakers today. Thanks so much for being with us, Angelo.
Great. Well, thank you, Katie, and thanks to all of you joining us this morning, and especially our colleagues in environmental health. You know, before we meet our speakers, I'd like to just take a couple of minutes, as we do typically when we start these, to sort of set the context or remind us about the context for our discussion. Our goal in this webinar series is really to understand, bring ourselves up to the right knowledge base on the current water crisis and how those of us that are working in environmental health can help to resolve that crisis. Within the state and in our region, the challenge of the century really is to develop a water system that provides adequate water and in a way that is sustainable indefinitely and despite the periodic drought conditions that we incur. I think many of you realize that the current drought that we're looking at is really not the best example. I mean, it may be a graphic example of the problem we have, but essentially it's reflective of not having a system, a water system that is sustainable. And that's why we're so sensitive to really natural phenomena. These droughts are with us. They're going to be with us forever. And I think it has more to do with the lack of sustainability in our water system. And when you think that most of our water, 80% of it, comes into our Southern California region from external sources, from outside the region, you can understand quickly. I think it's easy for all of us to see that we do not have a sustainable system. Now, as we're working toward developing that sustainable system, a big part of that is with the development of alternative water sources. And our part in that, our part as local environmental health jurisdictions, is really to help promote and facilitate the development of these alternative water sources, but in ways that are still protective of our existing water supplies. So we have this dual role in environmental health. It's a bit new for us because historically, when we didn't worry too much about where the water was coming from or whether we had enough of it, our focus was really on just protecting our existing water resources. But as we've said before, we now need a dual role, and that is to help promote alternative water sources and conservation measures, because both of those are going to be necessary in order to meet our water needs, both water adequacy and water quality. Okay, now let's be clear. Environmental health jurisdictions and our colleagues in public health are really not the driving force behind the development of alternative water in our state. But the question for us to think about is how we can assist the key stakeholders that are. And we're talking about the water municipalities, the private water companies, public interest groups, and other non-governmental organizations that are acting in the public interest and of course state and local regulators. And we have to figure out how we can best support innovation in the development of alternative water and how we do that in a way, again, that maintains the safety of our current water sources. I think our two panelists are going to be very helpful, at least with one aspect of that, and let me move into introducing them at this point. Before I do that, though, let me just remind everyone this is going to be an interactive session, and we'll be talking with our guests, and as usual, we're going to be inviting you to inject questions whenever. You can raise your hand, as Katie had mentioned. You can submit those questions in writing, and we'll have an opportunity for you to actually raise them as well over the phone line. Today's session focuses on black water. I'm really interested in hearing this as well. We will start with a case study of an innovative wastewater treatment plant in, is it Grayton or Grattan, California?
Grayton.
Sorry about that.
That's right.
That's in Sonoma County. And we're going to hear the perspective of project leader Bob Rawson on ways that regulators can support innovative projects like this one and others. Bob has been the general manager of Grayton Community Service District for the last 10 years. Bob conceived of and led the design and construction of the state-of-the-art wastewater filtration facility that he'll be sharing with us in just a minute. Bob is an international industrial wastewater solutions consultant. He specializes in operations, environmental compliance, and design of wastewater treatment and soil bioremediation projects for both municipal and industrial clients worldwide. He holds several patents related to wastewater treatment, and he has almost 40 years of experience in wastewater treatment processes. Following Bob, we will be hearing from Nick Weigel, and Nick is with the Decentralized Water Policy Council, and he's going to be providing us with policy recommendations in support of effective black water management. Nick is a senior engineer at North Star Engineering, where he specializes in the design of centralized wastewater collection, treatment, and dispersal systems. He's a member of the executive board of the California On-Site Wastewater Association. Nick teaches multiple courses for the California On-Site Wastewater Association and is a certified National Association of Wastewater Transporters instructor for the On-Site Wastewater Systems Inspector certification and the Operations and Maintenance certification courses. Nick is also on the Professional Advisory Board for the Department of Civil Engineering at CSU Chico and is chair of the Butte County Wastewater Advisory Committee. Okay, at the end of the hour, we are going to have a discussion, and again, we'll encourage all of you to submit questions throughout the hour. I'd like to now turn the floor over to Bob Rawson. Bob?
Hi, thank you for that nice introduction. I should just sort of dive in because our time's limited here, but there were certain drivers that got Grayton going. We took control through LAFCO process with the goal of local control from the Sonoma County Water Agency in about 2004, finalized in 2005. And so one of our big goals was local control of our water and sustainability. Of course, we were concerned about compliance because we were in a situation where we were out of compliance when we started with the Basin Plan, Title 22 requirements, and PDS permit. And we wanted a holistic sort of permacultural approach. If you put some of those slides on, I can flash up the redwood forest there. We started in 1999. That's our treatment plant. The next slide, I believe, has it there. There's a redwood forest planted by the community. So if you back it up one, please, to the redwood forest. That was planted by the community, and it got community involvement and support behind our project. All the residents in Grayton are on wells, and yet they connect to a wastewater treatment facility. And so local groundwater is important to us, and I appreciated your comments about groundwater and how important water is. We wanted to maintain our water within our basin because it sort of cycles several times through, and so one of our goals was to keep the water in the basin, and we chose this redwood proposal initially as our plan, low tech, because it had the ability of being expansion and contraction. A wet year, it would take a lot of water. A dry year, it wouldn't take any water. And so we could maintain all of the water in its maximum beneficial use, because we sell the water also to grape growers and people who irrigate, farmers to irrigate. So we had a number of other concerns, greenhouse gases, and within the construct of a limited lifetime, trees take time to grow, so it took us a while, and we realized that we were not going to be able to meet the basin plan's zero discharge objectives by simply planting a redwood forest. So we set out, got monies. Fortunately, we were able to get, we had a flood, so FEMA and CalEMA came in with about $4 million to help us out there, dredge our ponds and such, build a flood wall. And then we got Prop 50 monies, and we also got SRF and Prop 84 monies. All those revenue sources were extremely critical to our ability to build a treatment plant. And when we realized we had to build a plant, we wanted to build one for the future, not for the past. We rejected the idea of activated sludge. We had existing treatment ponds, and those ponds have the capacity to treat all of the waste in a way that was able to remove endocrine disruptors much better than an activated sludge system. So we wanted to look at that, and we realized we wanted to keep our footprint small, so we wanted to deal with our biosolids on site. We wanted to just reclaim and reuse every erg energy we could get. So we went on and built a treatment plant that met those criteria. You want to move on with the slides there? This is the treatment train has 3 ponds, 2 oxidation ponds that are 10 feet deep, and in the middle of them there's this #1 control structure. The device in front of you is a white knight. That's one of my patents I donated to the district, and behind it a tank to grow bacteria. In this case, it's an Animox system. The bacteria are used to inject it into that well there, and what happens is that the water from the final settling pond is pumped to this well and then mixed with bacteria and then pumped to the headworks. And the benefit of this is that the nitrified water in the settling pond reacts with the ammonia in the incoming influent, and the reaction with the bacteria results in a denitrification by way of ammonia oxidation. And so that's a white knight in the front ground, and we use a bacteria called IOS 500. It's got three bacteria in it, that one of which is a very strong Animox microbe. You want to move to the next slide, if you would, please. There we go. So Lescure Engineers was our engineer and on the project, and I worked very closely with Pete Lescure, and we were able to to collaborate and design this system together. We went to lots of conferences, interviewed with lots of people, and looked for the best technologies that were out there. And I think we achieved that goal. We used about $450,000 of Prop 50 funds to develop the testing and proof of process to use a SAF, a suspended air flotation, and a fuzzy filter, which we incorporated into the design. Want to put the next slide on, please? Hello? There we go. Okay, and you can see here, this is the footprint of the plant. You can see on the left, the building, there's a chemical mixing tank, which is used as a coagulant. And behind that, behind the building, there's a tall tower there. That's the fuzzy filters, or the Schreiber fuzzy filters. So the process takes water from the settling pond and runs it into this tank, pumps it into this tank, reacts it. Then it goes to the next tank to the left there. On the right hand side, you see the tank with the triangular base. That is the SAF, or suspended air flotation unit. What happens is tiny air bubbles and a small amount of surfactant are injected in there, so it's a very efficient way to float solids. So what happens is that the solids float and are skimmed off, and the clear liquid goes underneath the weir onto the next process. That produces a turbidity of 1 NTU, which is already a Title 22 quality, but it doesn't meet the Title 22 standard of having been filtered yet. So the solids go on to the composting facility, and the liquids go on to the fuzzy filter, or the Schreiber fuzzy filter. Would you move the next slide? Next slide, please. Thank you. Okay, that's the top there, and that's where there is the fuzzy filters right there. You can see those little pink balls on the left-hand side. Those are the media, and those media are compressed to the desired turbidity by a feed screw on the very top. You can see those. It looks like a little tube on the top, and depending on the compression, you can get as the desired turbidity. Our system puts out a turbidity that meets the Title 22 requirement of 2 mean, 5 max, 5% of the time, but it always achieves a 1 or better out of the SAF, and so the fuzzy filter brings it down to sometimes, say, a half an NTU. So it's a very, very effective system there. Next slide, please. Okay, after it has been filtered, after the water's been filtered, it goes to this piece of technology by Ryan Technologies, PTG Ryan. It's the pasteurization unit, and the pasteurization unit is novel. It's the first in the world, so we're pretty happy with it. We brought in natural gas because of the price. We didn't have digester gas, so we would have used that. And so what we have, the yellow box that you see in the center is actually a 30 kW capstone microturbine. And when it burns, the gases from that microturbine, about 200 degrees or so or better, are coming out and heating the water gas interface. You see on the right that blue box. And then beyond that, there's a heat recovery unit that's the blue in the background. And it takes about 10 seconds. And we were initially rated at 180 degrees Fahrenheit, but they were able to, with cooperation with Public Health Department people, able to bring it down to 167 and show positive disinfection. And this is a beautiful system, I have to tell you. Next slide. It is Title 22 certified. Next slide. You can see how the water temperature of the system works. The wastewater comes in at the ambient temperature. It says 70, but whatever the pond temperature is, it gets preheated, and it goes through that heat recovery unit and then back out the and so what happens is it loses about 3 degrees one way and gains it about 3 degrees the other way, and so heat is constantly being reused, and that's sort of a very efficient way of taking waste heat and affecting a pasteurization process. So we would like to be able to get every little erg out of it. We still haven't figured out how to get all of the heat, but we get probably 80% of the heat out of it or better, and we're generating electricity, which satisfies most all of our electrical needs for the tertiary process and aerators, and also at a lower cost. It's about 9 cents kW after calculating in the cost of replacement of the capstone. Next slide, please. Okay, so I told you we had a SAF, or suspended air flotation device, and the SAF removes the algae and bacteria from the wastewater. In an activated sludge system, we would have this water would come off the bottom of the secondary settling tanks, and it would be dewatered. But in our case, we have ponds, so the SAF acts as a replacement for that, and it removes the solids, and so we got to dewater them. We decided to use a simple gravity system rather than spending a lot of money with a second dewatering system that would have used more chemicals. I didn't want to use additional polymer and chemicals when we were already using some to achieve the removal. So we dewatered the solids in 4x4x4 bins, drain bins, on straw, and when they're dry, we dump the bins onto sawdust and wood chips. Next slide.
And Bob, this is the 3-minute warning you asked for.
Okay, thank you. So this is the composting facility. You can see Hopkins Composting Consultants helped us install the system, and it's a biopile gas scrubber. I'll show you in a minute here. This is called the aerated static pile system. Next slide. Next slide. That's the gas scrubbers. You can see we have a tank. We're growing bacteria, some more of the same kind of bacteria that I use in the other part of the system for odor control and vector control and acceleration of the composting process. So I've got another White Knight nursery tank back there with IOS 500 bacteria in it. Next slide. This is pond before or after the flood, but before we removed and mined the solids. FEMA would not remove the organic material that had accumulated over 35 years, so we used bacterial remediation, and we saved about $130,000 by taking about a foot of the solids out of the pond. So you can see the before and after. That saved quite a bit of money for the district. Next slide. That shows, that's just the paperwork. It documents the reductions. Next slide. Here's an example of the same technology being used in a septage receiving station and also in a commercial grease trap. You can see there's slight modifications, but it's basically an airlift with media and aeration and bacteria is the mechanisms. They use them on mounds and various other things as well, septic tanks. Next slide. Next slide. Here's another product we've been using called Aquamarine Shadow, which really helps on reduction of NTUs and the total suspended solids. We keep it down between 1 and 3, and that prevents all that regrowth of algae, which causes irrigation sprinklers to plug up and also permit violations of discharge. Next slide. That shows the reduction in algae. Basically, the TSSs and algae are kind of hold their same, you know, are sort of surrogates for one another. Next slide. I'd like to just say that there are opportunities to assist agencies with project funding, because projects require time, money, and planning, and these are all in scarce supply for small districts. Most small districts don't have a depth of staff to do hardly any of this. There are a lot of legislative burdens that force managers to exercise a real triage with the limited options. Most districts and organizations are conservative and risk averse, and they're constrained by their perceived options. So they often go for the rubber stamp of what everybody's done before rather than looking forward. Clients, they need some coordination and assistance to negotiate all the requirements, the application process, the follow-through, and they need coordinated cross-pollination to educate and encourage the agencies that they're working with. The cross-pollination is really important, I think, because you can carry a message because you're going like a bee from one district or one client to another, and you can tell one group what somebody's doing and how successful it is and what the problems are. Next slide. So how can public health policy be made a little bit more sustainable? I would say reward progress toward meeting standards with some flexible timetables. It's very difficult to meet those timetables when you start out behind, which we did, and we were running for 10 years to catch up. If you can support sustainable methods of compliance and coordinate with funding agencies to support grant and funding applications, that's really important. It helped us. Our people really came through for us, I think, every time. Be a physical presence and educate the client about the funding opportunities and about sustainable emerging technologies. Acknowledge success and, like I say, pollinate the ideas. Next slide.
Great.
These are some of the people I'm pretty grateful for. We had help with the regional board. Kathy Goodwin was our person there, and Randy Bernard helped with the drinking water State Water Resources Control Board, expediting Title 22. Andy Salveson at Carollo. Abby Killian got us the money. She helped me get the money from SRF, Prop 50, Prop 84. Pete Lescure Engineering, he thinks outside the box in sustainability, and he helped me to get that done. Andrew Lawrence, Megan Brown, James Vaughn, Jeff Albrecht, they came through, they got us the money, and we needed about $6 million from the state, plus about $1.3 million from Prop 50. And Ellen Hopkins of Hopkins Composting Consulting, she helped us with the permitting processes. Jennifer Lyle, Sonoma County Solid Waste Management, expediting permitting. Janice Oakley, I believe I think she's changed her name now. I should have updated that. Early involvement in the grant process, participated with our groundwater management planning and a lot of other things like that. And James Johnson, Sonoma County PRMD, Well and Septic. He's been inspirational. He's got some really inspirational projects going in the on-site that you might be interested in with using fungi.
Bob, we're gonna maybe we just put a bookmark in it there. I think that was your very last slide. And we're just going to need to move on to Nick here. There are a couple of questions that came in for you, but we'll just hold those for the discussion question at the end. But everybody, if you could please continue to send your questions in, that'll be great. And Bob, thank you so much. And just to reiterate some of the things you'd said in your earlier slide about the kind of support that you got from county environmental health was, the flexibility, supporting sustainable methods of compliance, the coordination with funding agencies in supporting grant applications, and really being a physical presence, educating clients and emerging technologies. So those are some things for us to hold and keep in mind as we go on. And thank you so much. It was so inspiring to hear about that your work there in Grayton. a great case study. So let's go ahead and move on to Nick. Nick Weigel, who's here representing the Decentralized Water Policy Council. Nick, I'm going to go ahead and unmute you and invite you to share with us.
Great. Thanks for the invite, and thanks for the intro, Angelo. My marketing department did a great job of pumping me up there. So I just want to start with talking about the Decentralized Water Policy Council and decentralized water in general. And what I'd like to say first off is Bob's project is an example of what can happen, but if you look at the coordination that it took to put that together, it's not the norm. And I think one of the main things that the Policy Council wants to do is get to a point where these types of innovative approaches are no longer innovative, but they're the standard process for dealing with systems in a sustainable manner and reusing our water and keeping it in the watersheds that it comes from. So going to try to push forward on slides. Do I have control here? Or are you going to do that for me? So let me, just a quick, I don't want to spend a lot of time on the Policy Council itself, but we have a broad membership that is divided into working groups, and we're working on developing an action plan that can be put out for environmental health directors and their staff that can assist in Angelo's vision of helping public health officials catch up. You guys are kind of our first line of defense and last line of defense when it comes to public health, pretty much taken for granted. And you're going anything from body art to food, swimming pools, and environmental health in general is just it's a huge vast wealth of knowledge that you need to have. Similar to civil engineers, and I think that's why I have an affinity for dealing with environmental health specialists in general. You're just jacks of all trades, and you need to know a lot of stuff. And so one of the things that I think we can do is help bring that education process up from where you're protecting public health through point source, maybe into the building and into the environment, but not really thinking about the hydrologic cycle and how you can impact the hydrologic cycle through your efforts in permitting, in your ordinances and regulations, and in your encouragement and partnerships with innovative people in the industry. So my hat's off to you, and I hope we can continue to work together going forward. Kind of a definition of decentralized water systems. This comes basically from CIDWIT, which is the Consortium of Institutes for Decentralized Wastewater Treatment. And I think it applies to all colors of water. I mean, we're talking about black water, gray water, rainwater, stormwater, groundwater, surface water. But we learned in grade school that they're all part of the same hydrologic cycle, and we've done a good job of compartmentalizing them and saying that this water is not that water. And I think the drought has kind of really emphasized the fact, or brought us back to our original basics and fundamentals that we have one water. It's all integrated. And so how do we use that, and how do we protect it, and how do we make the most of that resource? I keep looking back to the previous speakers, Angelo and Bob both, and saying, these guys hit it right on the head. This is a long-term issue. We have been pretty fortunate to have water sources that we can use once and send down the road, but the drought, in this drought in particular, is reminding us that that's not really a sustainable way to deal with our water. It's one of our most precious resources. So just keeping that in mind. So we're talking about, for decentralized, there's a lot of definitions going around, but I like to focus in on this one. Basically it's the water that is collected, treatment, and reuse at or near the point of waste generation. And why is this important for me? It's important to me because we're talking about the water energy nexus, and sustainability. You can push sustainability off and say, well, this water system is really sustainable because we're reusing it, because we push the energy into the background. And so if we're pumping water from miles and miles and miles away to get it back redistributed into the watershed or redistributed into the collection and dispersal system, through, say, maybe purple pipe on-site reuse of treated Title 22 water, there's an embedded energy in there that we need to keep in mind. And so one of the advantages of decentralized is potentially shortening that distance which also, of moving water, which shortens the cost and the energy inputs to get it to where it needs to be. So that's kind of where I like to focus on that as far as a definition. We move to the next slide. Maybe. Here we go. So we have, addressing California's water issues, we have kind of the buzzwords that everybody likes to talk about, and they're all important. Greenhouse gas emissions, climate control mitigation, that's back to the energy nexus. Localized energy savings, back to the energy nexus. Conservation and lower demand for new water. There's a finite amount of water here, and we've been, like I said, pretty fortunate. We can spend it with abandon, but we're finding out that our savings account is being impacted pretty severely, and we need to pinch our pennies, as it were, and keep that water in the watersheds and reuse as many times as possible before we send it down back into the hydrologic cycle. Addressing our failing infrastructure. If you do any kind of research on ASCE, American Society of Civil Engineers, and their report cards on infrastructure, we're C- at best in water and wastewater distribution, so that's a big issue. And protecting groundwater and human health, obviously, is another main component. I think if you look in the United States, we've done a tremendous job at protecting human health, and groundwater. We may have let that slide a little bit because it's out of sight, out of mind. But we definitely need to address that going forward. But here's the big one for me, and it's protecting the environmental and public health. This is right up your alley. I see this as a great place for performance-based codes that we'll talk about here in a second. And I know there's some focus on removing solid waste management, and so maybe the carbon sequestration through diversion of composting toilets. All those types of things can come into play here. And people ask, well, what about performance-based testing? What about, what does that mean, and what is a performance-based code? And not really thinking about that in our daily lives, but your emissions tests, your smog tests on your car are a perfect example of using performance-based codes for compliance and for improving the environment. I wish I had a couple hours because I could just talk forever, but I'm just going to kind of touch on some highlights and make sure we have room for questions on the backside. I seem to have, there we go. So what about the Policy Council, and what about our goals? So we've met as a collective group. The entire council has met and tried to define, okay, if we're going to come together and work together, what are some goals that we can all agree on and kind of channel our energy? And so we've gone through and kind of narrowed them down into these 6 main goals, which is appropriate regulation by scale, streamlining the approval processes, and this is where your groups come into play. You're a key part of that approval process, and making sure that you're involved in the process and educated, and educating us is really important to making that streamlining happen. Greening of local agency management plans for on-site wastewater treatment systems. This is back to the sustainable. Green is it's a nice trendy word. In Northern California, here where I am, we're not as impacted by demands on water. We technically have plenty of water, but there's always a reason to have better environmental outcomes. It's quality of life, nothing else. Public education and of on-site reuse. This is a pretty good topic. Bringing this up into the forefront is one of the main goals of the Policy Council, and also the California On-Site Water Association. Our main focus is public education and education of regulators and stakeholders in our industry. And kind of our background mantra is if people have access to the right information, they'll make the right decisions on their own. They don't need to be told what to do. A water budsman we'll talk about here in a second, but if you look at the list of collaborators on Bob's project, and he said you need someone coordinating these. There's so many things going on. Can we use that water budsman as a tool? And then reducing the size of leach fields with gray water and composting. That was a specific goal that may or may not apply to this discussion here. I'm just going to kind of breeze through some of these recommendations, and you can look at these. And I'm more than happy, as the rest of the Policy Council is, to field these specific questions and then start a dialogue. So here's a few Blackwater recommendations for appropriate scale and just some thoughts to think about. My big takeaway is on the regulation by scale is if you think and look at Title 22. Title 22 was, not really conceived to address decentralized wastewater systems. So we're talking about remote areas, rest areas, small communities that are not on a centralized sewer. Those types of institutions aren't really even considered. So getting another layer or another look at Title 22 that allows us to use current technologies, analytical processes, and data processing, redundant systems in disinfection to overcome some of the challenges that they faced when they wrote Title 22. And so just a refreshing of Title 22, I think, is one of the biggest looks at appropriate regulation by scale, as well as getting a lot of the regulations back into the local agencies, into the watersheds, where it can make the most sense, and eventually integrate with Groundwater Sustainability Act and groundwater sustainability plans that are going to be coming through in the next 20 to 25 years through the recently passed Prop 1A. Streamlining the approval process, Bob spoke to that. Using processes like the Efficient Landscape Ordinance. You have a Model Efficiency Landscape Ordinance in the state that's going to be coming your way, and looking at that to evaluate alternative methods. And that kind of segues into the water budsman. If you have alternatives analysis, you're going to need somebody that with expertise from a broad range of informational reservoirs, for lack of a better word. So we can look at the Missouri, for example. They have some examples that we're looking at to incorporate into some recommendations from the Policy Council to you folks. And also thinking about encouraging innovation, innovation labs, and direct funding. Bob hit it on the head again. It takes time, money, and planning, and you have to have them all. You can't make a project go without all three of those. So, and some of these projects are, dramatically changing the way we think about water is a project from an engineer's perspective, anyway. And so, just keep encouraging innovation. And I'm not going to name names, but I have a great a regulator that I really respect, that I work with pretty regularly, and his philosophy is, how do we, our job as regulators has shifted, he says, from compliance-based to education-based. And so how do you move from compliance, telling people prescriptively what they can and can't do, to teaching them what they need to do for public health and safety and sustaining the environment, and then looking back to them and saying, how can we solve a problem together? And some of these potentials are through on-site reuse and distributed systems, including composting toilets, using non-potable water for flushing toilets. This seems like a no-brainer. I'm working with a project with Caltrans, and we can't do this. We can't do this because of cost. Even though we're putting water cleaner than the water that's used to wash the floors in the rest area, we can't put that water in a toilet and flush it because it's a public health issue. integrated on-site systems. So this is an on-site system where we're integrating gray water, black water, rainwater, and stormwater to take advantage of whatever part of the hydrologic cycle we have available to us, and maximizing the efficiency on a scale, on a local scale, getting water back into the groundwater, back into the watershed, and rather than putting it into a pipe and sending it out of the watershed and out eventually into the ocean.
And Nick, this is Katie. I'm just going to give you a 2-minute heads up. Great,
thank you very much. Like I said, there's a million things we can talk about here, so I'll skip greening the lamps. That's probably self-explanatory. Reducing drain field size, that's kind of getting into the weeds a little bit, so I'll push past that, but I'm happy to talk to anybody about that going forward. So kind of some questions that the Policy Council has on the flip side is, from the environmental health perspective, what are you wanting to permit that you can't? And what are you using performance-based standards? And if you are, what are the pros and cons? And if you're not, why not? What are the issues? And any other kind of regulatory hurdles, policy hurdles, education hurdles that you may have that the Policy Council should know about as we put out our recommendations. And here are the steering committee members. You can reach out to any one of us. And again, James Johnson, he's there for a reason, and he's mentioned by Bob for a reason. Very innovative guy, very visionary, and we're more than happy to take a shot at helping you all out with bringing you up to speed, and then on the flip side also sharing information that you have with us, because it's really about education, communication, and sharing knowledge across our various disciplines. So with that, I think I'll leave it there and be ready for some questions.
Great, thanks so much, Nick. So now we're just going to be moving into our discussion period. We've got all of our panelists and Angelo on the line here. I just wanted to invite everybody to send in questions, raise your hand in particular if you'd like to speak. We'd love to have your voices on the line. And just to kind of enter us into that, we heard this great case study from Bob with some really innovative aspects, this pasteurization process, which is kind of pushing the envelope, the composting of biosolids, which will be applied to the land in agriculture, the water being reused, and some other really innovative aspects. And then Nick, really summing up some of the needs that he sees in the field from a real, systems perspective to really shift the dial here, as well as some recommendations in a few different areas. So I'd love to just put out to the audience, any thoughts, questions, anything you'd like to share about what you're doing. But it'd be really great to focus in on, what would be most helpful to you in terms of support for policy change to facilitate these kinds of black water innovations. Are there any particular, areas that you'd like to see support happen? So we've got a few questions here from the audience. I'll go ahead and ask those and just invite you all to think about it a little more. One of our audience is asking, could you please say a little bit more about the tension between environmental health and the expansion of the use of on-site approaches such as composting toilets or use of non-potable water? Anyone like to field that question?
Could you say that one more time?
Yeah, just an interest in saying a little more about the tension between environmental health and the expansion of alternative water approaches such as composting toilets.
That's an interesting word, tension. Yeah, I'll speak to this. And again, I really kind of resonate with regulators in particular. Civil engineers in particular are very conservative by nature. We need to make sure things work. We have safety factors. We don't get a second chance to do things. Regulators have public health and safety in mind, and most of the engineers that are in the public sector, their bottom line is their livelihood, their reputation, and their ability to make a living, and we can't get too far out over our skis without risking all three of those. So I think the tension, and I will feel it as well, so I'm kind of projecting that into the regulator field, is lack of information, fact, data, something more than passion and a theory, to change something that's been institutionalized since the 17 and 1800s. And so I think that's the tension. The tension is, it sounds good, it looks good, I think that's the right feeling, my gut tells me it's the right thing, but I have public health at risk, and if I make a mistake, it's on me, it's on us, and it's on our regulatory industry.
Right.
So I don't think it's animosity more than it is just an understanding of where people are in their roles in society.
Right, and I guess the reality is, with issue like composting toilets, we're in the 4th year of a severe drought, as we all know. If we have one more year of a drought like this, we risk using the last drops of water in some of our reservoirs in the state for flushing toilets. And as you mentioned, there's a real need to match the water quality to the use. How that happens on short order is one question, and then how we foster longer-term solutions is another. Another question from an audience member here is, how do we encourage performance-based standards at the state and local level? What does that look like?
Yeah, I don't know if Angelo has any thoughts on how to do this. It is a challenge. I think one of the main things that comes down to that when people are addressing performance-based standards is that if you're going to have performance-based standards, you need to measure performance. And if you're measuring performance, that takes money. It also takes regulatory oversight to review that data and make sure that it is in compliance. So there's there's definitely a funding mechanism that has to be considered at the state level, because the local level, they can't continue to take on unfunded programs. So I think as far as performance-based, that's probably the Achilles heel of performance-based is there's two things. One is you need to pinpoint exactly what your performance-based criteria is and why, and not test anything else. And then you need the funding on the public side and the private side to be able to make sure that program can actually function.
The only thing I would add to that is that a lot of our environmental standards are very prescriptive. We really like engineers who are designing projects, we like prescriptive standards because it's easier. But I think some of the most complex problems we deal with in the state, have to go toward a performance-based standard. But as you just said, Nick, it's much more complicated because there's greater monitoring and there's greater costs associated with that.
Yeah, and I think one of the ways to maybe mitigate that is to allow pilot projects where you can spend the money on a specific project or technology to understand what the performance base is, using that as a performance base until some time that we understand how they work, and then you can move back away from performance base and back into prescriptive as the technology or the operation is approved and considered long term.
Right, and I think, I just wanted to add that I think, I'm very optimistic about where we're headed here. And the reason why we can be optimistic is because a number of us have actually seen the technologies demonstrated and how useful they are. And I think that's the key. We really are, with both of our speakers and those of us in the environmental health jurisdiction, we really have a partnership here. And information and sort of a greater understanding of the vital nature of development of these alternative systems to public health, I think just understanding that is going to open the floodgates, and I think we're really going to be working together toward developing these. But it's the question about what does environmental health need. We first have to get to the stage where those of us in a regulatory role are actually looking for ways to promote and encourage these innovations. And I think once we're there, it'll be easier for us to say to one another, this is what we need in order to approve these systems and support them to a greater degree. But I think the information is still ahead of us. I don't think we have to first focus on that so that we can spread the word and we can all get engaged and supportive of this innovation.
One of the
important point, Angelo. I just wanted to note too, we've got several other questions
and
a couple of raised hands. So why don't you go ahead and have the last word, and we'll move on to a couple of other questions.
I have a really quick point on moving the needle, and you know, the essence of public health. We can do whatever we want for public, but the essential key component of public health is access to water. And if we don't use innovations and we don't think of that in terms of public health, it doesn't matter if nitrogen or fecal coliform is 2 or 10. If we don't have water, that's the baseline of public health. We're dead. We're done. So allowing those innovations to happen.
Good point. Let's go ahead and hear from Larry Fay, a participant who's got his hand raised. Larry's the Environmental Health Director in Santa Barbara County. Larry, did you have a question or want to chime in on the discussion?
I do, actually. Can you hear me?
Yes.
Great. Hey, wow. First off, I don't even know where to begin. There's so much I could talk about here. I can say I have pondered these issues for 25 years as an environmental public health official, and not just in California, but other parts of the country as well. I actually have a question for Bob and a couple of comments related to Nick's talk, and I think I'll start with those two comments. I agree that there is a huge missed opportunity in looking at water recycling on almost a project basis. Our whole system on recycled water is based on traditional big pipe technology, and there are huge costs in infrastructure, huge costs in energy, and lots of lost opportunity. And to the extent that we can work on simplifying, streamlining, and coordinating the regulatory process around decentralized management on water and wastewater, you know, we need to, public health folks need to be right in front with everybody else on that. Specifically, you know, I've been looking at gray water issues in particular here in Santa Barbara County, and I'm working with a gentleman here that you're probably familiar with, Art Ludwig with Oasis Design. And I'm just trying to wade through the relationship between the building code and my role as a public health official in Title 22 as we start looking at recycled water projects and working with multiple permitting agencies when you talk about the different cities and counties that have jurisdiction. So it's challenging just from a bureaucratic standpoint to move forward even when you want to. So to the extent that the Decentralized Water Policy Council can drive some kind of state coherency with the regulatory system that we can get on board and support, that's great. For Bob, I really want to go back to that water pasteurization system. I just about jumped out of my seat. I thought, what a simple concept that I hadn't seen in a small wastewater project before. How scalable is that? Is that something that can be used in a relatively small community system? Or to give me some perspective, how many, what is the size of your facility up there in Grayton?
We're at an average dry weather flow rating of 140,000 gallons a day. So, yeah, it's very scalable. We're probably at, with regard to generation with the capstone, at about the small end of scale, but you know, that's just one particular manufacturer vendor. They're putting out about 28 to 30 kilowatts of power. And if you were putting it back on the grid, of course, the wasted power would be easily sold, but the heat probably would not be all recoverable unless you had, like a business going with you, something, home heating of multiple homes, or you know, something that with food manufacturing or something like that that had in a community where they had the opportunity to take advantage of that waste heat in boilers or other things. But I believe it's scalable upwards.
I'm sorry, Bob. I think this is a really super important and interesting, but I just, we're at time here, so I'm going to have to cut it off there. But I do want to make a commitment to everyone who has sent in questions that I will follow up with our speakers and hope to get those questions answered and sent to the entire audience. If anyone else has questions, please feel free to email me, Katie Mauman, and my email will come up in a minute. And
you can post my email address if you like.
Great, thank you. We'll go ahead and do that. And I'm just going to hand it over to Angelo for the final word.
Just a quick couple of words here. I just wanted to say that Bob and Nick, you guys have been wonderful. Bob, you've really given us a great demonstration project, and when I think about the work that the Decentralized Water Policy is doing, it's really the power of one, you know, multiplied many times. I really think decentralized is the word, at least of this session, and it's where we've got to go. I want to also thank Katie and the staff at the Alliance, and I'll mention that we do have next up, September 25th will be our next webinar series on water reuse with a focus on model local policies and other concrete tools for regulators. And Art Ludwig, that was just mentioned by Larry, will be in attendance there. So thanks to everyone, really appreciate it, and we encourage you to spread the word to your colleagues so that we can get an even bigger number of participants next time around.
That was good.
Thank you all so much, and there's my email address there on the screen. Feel free to send any additional questions my way, and we'll follow up with an email within the next week or so. Thanks so much, everybody.
Thank you.
Thanks.
Thank all of you.